Hello friends, I am Swapnil Garad. Welcome to my educational channel Design Institution. Design Institution channel is focusing on increasing design knowledge among engineering students. Let's start today with the subject strength of materials. Today I am going to provide you few tips of metal properties. The important metal properties considered while designing. Requested audience is diploma students, degree students, postgraduate students, working professionals in design field, students preparing for interviews, and any other curious people who want to know more about design engineering. There are few important topics to be discussed in strength of material subject. Properties of metals, stress and strain, shear force and bending moment, torsion of shaft, principal stresses and principal strain, theory of failure, columns, springs, pressure vessels, deflection of beam. So in the metal properties, first property is elasticity, which is very important to know for mechanical design engineers. The definition of elasticity is that it is the property by virtue of which a material deformed under the load is enabled to return to its original dimension when the load is removed. When any specimen is loaded under tensile or compressive force, in that case, the material tends to deform to some extent within elastic limit, and when that load is removed, the specimen will regain its original shape and size. There are few points to remember for elasticity. If body regains completely its original shape, it is called perfectly elastic body. Steel, aluminium, copper, concrete may be considered to be perfectly elastic within certain limit. The next metal property is plasticity. It is the property by virtue of which a material deformed under the load does not return to its original dimension when the load is removed. First, we have learned about elasticity. Later, this one is plasticity. This is different than elasticity. It comes ahead of elasticity. In the elasticity, the material, when load is removed, material gains its original shape and size. But in the case of plasticity, when the load is removed from the test specimen, the material will not go to its original shape or dimension. It will be as it is when it is deformed. In that condition, it will remain the same. There are few points to remember. This property, plasticity, is particularly useful in operation of pressing and forging applications. So now you get it right. The plasticity is very important property for mechanical engineers or mechanical industries. There are few parts which require to be produced by using these applications, which are pressing and forging applications. Do you know that your car body is generated by using this application, pressing? The dies are created for this pressing application. So in the sheet metal of the car body, this plasticity is property is available. So that's why we can sit in the lavish car and transport from one location to another. So there are few applications like that where these properties are important. The next point to remember is that when large deformation occurs in a ductile material loaded in plastic region, the material is said to undergo plastic flow. I think you get it. Steel, aluminium, copper, these are few of the metals. It may be considered to be plastic beyond elastic limit. Let's go to next property, metal property, ductility. It is the property which permits a material to be drawn out longitudinally to reduced section under the action of tensile force. There are few points to remember about this property. A ductile material must possess a high degree of plasticity and strength. Ductile material must have low degree of elasticity. This is useful in wire drawing. Steel, aluminium, copper, these are few of the metals may be considered to be ductile. Guys, ductility is very important property for mechanical engineers or design engineers to consider. The ductile materials are these materials which are elastic also, which have this plasticity property also, and because of this property there are few applications we can use this property. Let's go to the next property, which is brittleness. It is exactly opposite of ductility. It is a lack of ductility. Brittleness implies that it cannot be drawn out by tension to smaller section. There are few points to remember. In brittle material, failure takes place under load without significant deformation. So when the test specimen is loaded, and if we put some compressive or tensile stress to it, or compressive or tensile force to it, it will not elongate because it is not a ductile material. It does not have elasticity or plasticity. So what will happen? There is no elongation, there is no deformation. So specimen will break when the load will go beyond its strength. So this is the brittleness property. Ordinary glass is nearly ideal brittle material. Have you seen anywhere that when you apply load to glass, it elongates? No, never. It will not. It will break when the load is applied. Cast iron is also brittle material. Concrete is brittle material. Ceramic materials are also brittle material. The next property is malleability. It is the property of material which permits the material to be extended in all directions without rupture. We can say this property is similar to the ductility. When like in some cases forging or any other application, if the specimen is hot to that temperature level, when you hammer on it, it will try to deform in all directions 360-degree, but it will not break and it can gain another shape and another size. The point to remember is a malleable material possesses a high degree of plasticity but not necessarily great strength. Okay, let's go ahead. Another property is toughness. It is the property of a material which enables it to absorb energy without fracture. Guys, the toughness is a different property than strength. Toughness is different, strength is different. Point to remember is that it is desirable in a material which is subjected to cyclic or shock loading. Any material, any component which is subjected to cyclic or shock loading. For example, your suspension springs. These are subjected to cyclic or shock loading. Therefore, toughness, this property is very much required in the springs. So while designing the springs, please consider this property, toughness. The next property to discuss is hardness. It is the ability of material to resist indentation or surface abrasion. If a material is hard, it will not allow for wear and tear. So it is the ability of material, but material does not have this ability from the start. We have to do some treatments on it to make material as much as hard possible. So there are few points to remember. The hardness of the material is measured by few units. There is one test which is called the Brinell hardness test. There is another test also which is called HRC. So in Brinell hardness test, this test is used for checking the hardness of the specimen, and this is the formula to check Brinell hardness number: P divided by pi d divided by 2, in the bracket capital D minus under root capital D square minus small d square. Bracket is closed. By using this formula, we can find out the Brinell hardness number of the test specimen. Here, P, capital P, small p, which is a standard load. Capital D is the diameter of steel ball in mm. Small d is the diameter of indent in mm. So guys, this test is about there is a test specimen which we can call a steel ball. Okay, so the diameter of the steel ball is very important, and there is another unit, or there is another component in the test which is called indent. Okay, so this indent is pressed against a steel ball and some impression will be made over there. So within this steel ball of the diameter capital D, the small diameter D indent will be pressed and that area will be measured. So this is how this Brinell hardness test occurs, or this test is taken, and we can find out this Brinell hardness number. The next property to discuss is strength. This property enables material to resist fracture under load. Okay, this is very important property for mechanical or design engineers to consider while designing any component. Remember, every material has its yield strength capacity and ultimate strength capacity. While designing, you need to consider these both strengths. This is the most important property of a material from design point of view. While designing, we must consider stress is not exceeding the yield strength of the material, obviously with some factor of safety. Suppose steel is having its yield strength about 5000 Newton. You are putting some load on the component and the tensile stress is coming to 2000 Newton. Okay, so if I consider 2000 Newton stress is coming due to some load, let's say 500 kg load, and 2000 Newton stress is coming to that specimen, but it is having yield strength of 5000 Newton, then it is safe. More than 2.5 factor of safety is considered. Okay, this is how we go ahead while considering strength. But if the yield strength is 5000 Newton of that material, but your stress is coming to more than 5000 Newton, then obviously that material or component is gonna break. It will not sustain. In that case, you will need to add, or you will need to resize it, increase the size, provide some ribbings. So this is how you are going to improve your design. Okay guys, let's see you to the next topic which I'm going to discuss with you, or I'm going to share knowledge with you. Next topic is stress and strain. Be sure to watch my next in order knowledge sharing session on the very basic topic of design engineering. The topic is stress and strain. Bye bye.